According to physicists, the universe had its origin in an event known as the Big Bang, approximately 13.7 billion years ago. However, the issue that arises is, what caused that explosion, and why did it occur? Over time, as we've investigated and learned about the history and science of the Big Bang, our universe has been the predominant explanation for everything we've seen so far. A lot of research, thousands of studies, has been carried out by scientists, and the data collected has always supported the Big Bang theory as the main reason for the way the universe was created. In accordance with this theory, dark energy is a form of energy even more abundant than the energy of the galaxy and is the force that prevents gravity from slowing the expansion that has continued since the universe began with the Big Bang. Today's science is very different from what it was in the past, and with technological advances, new theories emerge. We frequently discover that things we believe to be true in every way are not at all what they seemed. Michio Kaku has raised official disprovement of the Big Bang. This is because the James Webb Telescope has detected 750 new galaxies that look nothing like what was anticipated, bringing us to a new perspective and delving deeper into how the James Webb Telescope is altering our comprehension of the entire universe. Join us on this incredible journey beyond the far reaches of the observable universe to discover more details about the immense number of newly discovered galaxies found. If you're interested in keeping up with the latest information from the universe and everything around it, subscribe to our channel. Be sure to like this video, share it to reach more people, and turn on the notification bell. The images of brand new galaxies captured by the James Webb Telescope are absolutely stunning. We are able to see hundreds of galaxies in a single image, and the beauty and power of these photos are stunning, something that should not be ignored. However, what appears to astonish the typical person is the exact opposite for researchers. These images are amazing to them, but they do not match what the scientists expected to see based on their theories. In fact, there are many more galaxies visible than expected. Furthermore, these galaxies differ from the remainder. They are smaller than anticipated and are truly extraordinary in age. These surprises are causing some anxiety among scientists. There is even an article that begins with the word panic in the title, which demonstrates the seriousness of the circumstance. These galaxies are nothing like what they were supposed to be in accordance with existing theories. For a very long time, researchers have proposed the Big Bang theory as the main explanation for the vast universe's beginnings. According to this theory, the universe began approximately 13.7 billion years ago through some kind of mysterious cosmic event. However, these new images challenge the definitive tale of the universe's beginnings previously comprehended. These dazzling images captured by the James Webb Telescope have posed a challenge to the comprehension of the source of the universe. In particular, these images directly contradict the Big Bang hypothesis, which has long been considered an unquestioned truth by most theorists of cosmology. The galaxies depicted in these photographs appear to be too small, smooth, old, and numerous compared to the Big Bang's predictions. The observed galaxies are 2 to 3 times smaller than similar galaxies imaged by the Hubble Space Telescope, completely defying the expected behavior in an expanding universe. In line with the hypothesis, as space and time expand, objects should appear larger as distance increases. In addition, these James Webb galaxies that defy description are observed to defy that expectation. The age of these galaxies is totally unexpected. The Big Bang theory says that galaxies ought to exhibit anomalies and changes in their structures as a result of the dynamics of their formation and evolution. However, the images reveal extraordinarily smooth galaxies devoid of the level of roughness and complexity that one would typically anticipate seeing in galaxies of their age. This defies the expected order of events. For the structure and development of galaxies in the Big Bang theory's framework, at the beginning of all matter in the universe, energy and the elements that make up the universe were condensed into a remarkable singularity, which refers to a concentrated point. The density at this point reached an infinitely high value because of the extreme compression of energy and matter. The basis for the singularity concept is our current knowledge of the rules of physics, particularly the equations Albert Einstein proposed in general relativity. Einstein's theories suggest that the singularity, where all the universe's energy and matter existed, was in an extremely constrained form. This extreme density implies that an enormous amount of energy and mass was condensed into an infinitesimally small space under extremely high density and pressure conditions, such as those present in the singularity. The heat of the singularity is unimaginable. The temperature of the singularity would exceed any temperature that can be observed or reproduced with our current knowledge of the universe and energy. This energy was kept in this hot, dense point, the seed from which everything in the universe originated. We know where it came from. The singularity marked the beginning of the universe, the beginning of everything in our universe. After the universe's first singularity began its expansion journey and inflation, this process took place over roughly 13.7 billion years, giving rise to the universe as we know it today. The beginning of the universe's expansion was a remarkable and swift burst known as cosmic inflation. During this phase, the universe grew at an unimaginable speed, much faster than the speed of light. It was as though the very fabric of space stretched, pulling everything within it. Cosmic inflation played a massive role in the creation of the large-scale structure of the universe. It smoothed out and homogenized irregularities in the distribution of energy and matter, paving the way for the subsequent formation of stars, galaxies, and other structures of the universe as a whole. As the universe kept increasing, the rate of expansion slowed down over time. It is important to note that despite the rapid expansion of the universe during the initial period, the universe continued to expand at a measurable rate. This expansion is known as cosmic expansion, or the universe's expansion. Scientists have witnessed the results of this expansion through a variety of observations, such as the redshift in distant galaxies. Redshifts indicate that light waves expand as the universe expands, being stretched and shifted to longer wavelengths that move them closer to the red end of the spectrum. All the matter that makes up our universe was condensed into an extremely compact volume. It was abundantly clear that matter could not survive in such a small space, so transformations occurred as the universe cooled and expanded. Particles, like protons, neutrons, and electrons, began to interact with the light and energy around them. These interactions played a significant part in the formation of matter in the universe. In the beginning minutes after the initial explosion, this process is recognized as nucleosynthesis. Unordered and chaotic, multiple collision-caused galaxies were anticipated to be observed, but the pictures, as told by the James Webb Space Telescope, JWST, tell a different story. The images show spiral and well-organized disk structures, like the ones we observe in galaxies in the universe today. This unexpected observation casts doubt on the notion that galaxy mergers are common processes in galaxy evolution. In the absence of these new galaxies experiencing many or any mergers, it becomes unlikely that small galaxies will expand and transform hundreds of times larger than anticipated. This suggests that these galaxies never shrank in size originally. In addition, the optical illusion anticipated by the expanding universe, where objects appear smaller due to expansion, does not hold in this instance either. Consequently, what we have so far believed may be a falsehood. Furthermore, the age and abundance of galaxies revealed by the James Webb Space Telescope also pose a problem for the truth behind the Big Bang theory. JWST is equipped with filters that allow capturing images in the infrared region of the spectrum, which makes it easier to study the hues of faraway galaxies. By analyzing these colors, astronomers can estimate the ages of galaxies and stars.